Hey, seventh graders, welcome back. It is May 12th, and today we are switching gears, still working on geometry, but no longer working on those proportional relationships in geometry having to do with scale factor, scale copy, and scale drawings. Instead, today we're really focused on area. We're going to be working on area of composite figures. Do you remember what composite figures are? Composite figures are made up of multiple types of polygons. So what we'll see today are figures that are made up of rectangles and triangles to create maybe a trapezoid or another type of polygon. So we'll find the area of those by breaking apart into their pieces, into rectangular and triangular pieces. We will look at some area word problems today, and then finally we will find surface area. We're really just focused on surface area of rectangular prisms today, although you've done area of other kinds of 3D figures this year as well. So I just wanted to take a second and rewind us. What is area? Area is the number of square units that a figure takes up. And our units could be different sizes. In this picture on a coordinate grid, there's no labels for what units these are, so we just call them units. If I have a rectangle that's 1 by 12, I have 12 complete square units that take up that figure. If I have a rectangle that's 3 by 4, I also have 12 complete square units that take up that picture. You'll notice when you find the area of triangles, some of those units get split into smaller pieces. And so we can't use counting as we could in elementary school. But for many reasons, which we talked about during the school year, what we do when we find the area of a triangle is we multiply the base and the height, just like we do for a rectangle. And we understand that the triangle is half of a rectangle with that same base and height. And so then we divide that by 2. So my formula for a triangle is area equals base times height divided by 2. Okay. The other thing that we've looked at is the area of a circle. I don't have a picture here, but the area of a circle is found by this formula, pi r squared. Again, I love to talk about where that formula comes from. We don't have time to do that today. That's a great thing to YouTube later if you have some extra time. Awesome. What I want you to do now is just take 30 seconds. Please write down these 3 formulas with their labels. So what are the formulas for area we're going to use today? Go ahead and write down what I've highlighted. Do that now. All right, folks, your notes should look something like this. If you didn't get that title down, that's okay. Pause the video here so you can jot that down. Again, it's important to have this because, as I said, geometry is has such a wide variety of skills, concepts, and topics. And so yesterday we were talking about scale factor. Today we're talking about area. As we continue over the next couple of days, our topics are changing kind of wildly. So you want to make sure that your labels are there so that by the time it's the end of the week and you have your quiz, you can quickly go back and remind yourself, for example, what was the formula for area of a circle. Alrighty, let's dive in. We're going to start with a couple of area questions. The first is a composite figure, just as I promised. I want you to try this one on your own. You have the formulas you need. Find the area of the figure below. Enter the answer as square inches. So find your answer as square inches. This is a trapezoid. Go ahead and find its area now. Let's take 1.5 minutes. Go. We're about halfway through our time. All right, last few seconds. Don't forget your correct unit on your answer. All right, there's our time. If you didn't finish, no worries, you can catch up now. All right, so the first thing that I did is I went ahead and redrew the figure. I redrew the figure, just a brief sketch. You have graph paper. It's kind of nice to be able to use that to help you figure out how long length should be. But if you don't, no problem. You're not actually counting boxes here. I do also want to point out that I went ahead and added this label. I know I'm finding area, and when I'm finding area of both rectangles and triangles, I need their base and their height. So I can see this is a rectangle and this is a triangle. I had the triangle's base, but I did not have the triangle's height. Of course, I know it's the same as this measurement, so I went ahead and labeled this 6. Here's my work for finding the area of both the rectangle and the triangle. Okay. My rectangle's area was 30, my triangle's area was 12. If you got 24, you forgot to divide by 2. So make sure you divide by 2 every time you're finding the area of a triangle. Then I just add those two pieces together. 30 square inches and 12 square inches is a total of 42 square inches. Big star on your paper if you got that one on your own. Nice work. Let's try another one. This question is not the area of a composite shape. It is a word problem having to do with the area of circles. So I'm excited. Here we go. Go ahead and read it with me and we'll solve this one together. Number 2, Maya bought a new roll of tape at the store. It's pictured here. The smallest circle has a radius of 0 75/100 inches. The tape is 0 25/100 inches away from the small circle. What is the area of just the tape part? Okay, so let me just unpack what this question is asking. This question's asking, so here's where the tape is. It's asking what's the area of all of this space, right? My marker got a little messy there, but I shouldn't have gone outside there. But all of this space inside, that's what I want to find the area of. Do I want to find the area of this part? No, I don't. I'm going to go ahead and erase that part. I don't want to find the area of the inside. So this is like, I want to find the area of a circle with this hole in it. That's what I'm trying to do, okay? In order to do that, I'm going to go ahead and find the area of the outside. I'll do this one in blue. This is a good test of my fine motor skills / patience. That outer circle, I'm going to find the area of that outer circle. And I'm going to take away the area of this inside circle. So the smallest circle plus that gray part, I'm going to take out that area. So when I take the area of the blue minus the area of the green, that's how I get my answer, okay? So that's what I'm going to do. We'll write that down in just a second. Stick with me. Do you remember what radius is? Radius is the distance from the center point of a circle to the outside edge of a circle. So it's halfway across the circle. So this length right here goes from edge to edge. That's called the diameter. That's called the, yes, the radius is half of that. So from the center to the outside point, any outside point, okay? So let's go ahead and draw a picture. We'll write our steps out, and then we'll unpack what this part of the question is talking about, okay? Grab your pencil. This is question number 2. Okay, go ahead and draw a circle. Does not need to be perfect. And draw a small circle on the inside, and then one other small circle, a little bit bigger, around that. So this is that roll of tape And this is, I would call this like the empty section inside, and then some kind of core on the inside, like a plastic piece that the tape goes around or a cardboard piece. I want to find the area of just the tape surface, not of this middle part. So what do I know? I know that the diameter of the whole thing is 6. I know that in my formula for area, I have to know what the radius is. And the radius is half. It's that center point to the outside. And that is 3 inches. All right, make your paper look like mine. Awesome. I'm going to go ahead and label this radius 3 as well. I'm going to switch colors because it gave me some more information. It said, let's reread. It said the smallest circle has a radius of 0.75 inches. The smallest circle. So grab your pencil. If you want to change color, go ahead and do that. The smallest circle has a radius of 0.75. Okay, I'm not going to label that yet because there's a little more detail. The tape is 0.25 inches away from the small circle. So the tape is 0.25 inches away from the small circle. So this section right here, I'm going to do a dotted line, is 0.25. So together, those two measurements make up the radius of everything that's not the tape. 0.75 plus 0.25 is 1. So this section, this radius, is 1 inch. The whole thing is 1 inch. Okay? That was a lot of small details. The big takeaways I want you to remember, if I'm given the diameter and I'm trying to find area, I need to actually know what the radius is. So I just divide the diameter by 2 because it's half as long. And then in this case, I'm going to be finding the area of the larger piece and taking away the area of the smaller piece. All right, we're going to jot down a couple of steps in the question because there's a lot going on here. So the first thing that I want us to do is we're going to find area. Your paper looks like mine. Find area of large circle. Find the area of the large circle. The second thing we're going to do is we're going to find the area of this circle. I'm going to write small circle. It's not the smallest circle. It's like a little bit bigger than that, but that's okay. Find area of small circle. And then once I have those, I'm going to take away the area of the little circle from the area of the big circle to find how many square units are covered by the tape. So take away is subtract. I'm going to subtract the areas. Okay, we're going to do part of this together and you're going to finish part of it on your own. We're going to do the first step together. Let's find the area of the large circle. So I like to label my work. Let's go ahead and find the area of the large circle. The formula for area of a circle is, do you have it? Lock this one away in your brain. It's going to be really useful to you as you go into high school. Pi r squared. Pi r squared. Pi is a great number to talk about. We don't have time to do that today, unfortunately, but we approximate pi using the number 3.14. That's a really close estimate for pi. However, pi is different from that. So this is just an estimate. 3.14 is pi. R squared comes next in my formula. What's the radius of the large circle? Yes, the radius of the large circle is 3 inches. So I'm going to write 3 squared. Pi times r squared. Okay, next line of work. Should I multiply or should I do the exponent first? Thinking order of operations, GEMDAS, I'm going to do the exponent first and multiply after. So 3.14 times 3 squared is, did you say 6? I hope not. 3 squared is 3 times 3. 3 times 3 is 9. Awesome. Okay, grab your calculator, go ahead and solve. All right, friends, I got 28 and 26 hundredths. we have found the area of the large circle. But that is not yet our answer. We're going to find the area of the small circle, and then we're going to subtract them. Okay, you're going to finish that on your own. I'll put the question back up on the board. And please take a minute and a half to finish this question. About 20 seconds left. It's okay, a reminder just to use your calculator. Totally okay to do that. All right, let's review the rest of our work. All right, so where we left off is we needed to find the area of the small circle. It's a circle, so we use the same formula. However, the radius is different. The radius of the small circle is only 1 inch. So I wrote 3.14 times 1 squared. 1 squared is, yes, 1, and 3.14 times 1 is 3.14. So the area of the small circle that's not tape is 3.14 square inches. To find the area of just the tape, I'm going to go ahead and subtract the larger area minus the smaller one. And I got, here's my final answer, 25.12 square inches. Put a star on your paper if you got it. Really nice work. What a rigorous question. Awesome. We are going to enter this answer into our Google form for question number 2. When you do that, only type the number, okay? 25.12. If you put any spaces or if you make a spelling error, then the computer's going to mark it incorrect, and I want you to get it correct. So just typing in the number, please, into the Google form. All right, go ahead and enter your answer for question 2 now. Sweet. Now we're going to move on to surface area. So we did an area of a composite shape. We did area of a circle in a word problem. Whoa. And now we're going to do some surface area work. Today our focus is to find the surface area of a rectangular prism, a figure that looks like this. Surface area, remember, is the area of each side of a 3D shape, and it's the sum or the total amount of all those areas. So one strategy that I really like to use is thinking about all the different faces separately and adding them together, okay? So I like to think of the top sides area and the bottom sides area as together because the area of the top and the bottom are the same. Think about like a shoebox. The size of the lid is the same as the size of the bottom. Side 1 and side 2 are the left and right sides. If I find the area of one of those, then I know it's the same as the other side that I can't see in this picture. And the front and back, so this front face and the back face are the same. So if I find the area and think about it that way, I'm making sure to get all of my faces, even the ones I can't see. So let's try it. Guided practice question number 3 says, what's the surface area of the rectangular solid shown below? I can see this part right here is 3 centimeters. This dimension here is 17 centimeters, and this one is 6. Okay, so knowing that, let's go ahead and set up our paper. I want you to do this one with me because I want to remind you of the strategy and sort of work organization. Okay, I'm just going to label this as a surface area question. using SA. All right, if I want to find the surface area, let's start with the top and bottom. So what I do is I give myself a space where I can find the area of the face that's on the top and bottom. Remember, the top and the bottom are the same. I'm also going to find the area of the left and the right side. And remember the last pair? Yes, the front and the back. So surface area is the sum of all these areas. So let's go ahead and figure out the area of the top and bottom first. The top and bottom look like this. Hey, I'm getting better at this pen, you guys. Not bad, pretty proud of that. Okay, so here's the top, and remember the bottom's the same. What are the dimensions of this face? Yes, this sort of like height is 3, and the base is the same as this base, which is 17. So I'm gonna go ahead and do a quick drawing on my paper. And I'm gonna label it 3 and 17. Let's do the same for the left, right, and the front, back. So left, right, here's the right side. In purple, oh, this one's not as good. I spoke too soon maybe on my tracing skills here. All right, so the base here, what is the base here of that side? Well, this one's not labeled, and this one is not, but I know it's the same as this one. So I have sort of a base of 3 and a height of 6. Please label that. All right, and then the front and back, let's do one more color here. This one I think is the easiest because it's not skewed by 3D drawing. Looks like my base is 17, that got real wobbly, sorry, and my height is 6. So notice we have those dimensions 3, 6, and 17. Each one is used twice. That's a helpful way to double check and make sure you got it. All right, now what we need to do is find the area of each piece. And what I'm gonna do is actually set up just one at a time. When I think about the area of the top and bottom, I'm gonna think about it like 2 times the area of the top and bottom, because the top and the bottom is 2 separate faces. So 2 times 3 times 17. Okay, so this is 2 times 51. 3 times 17 is 51. And what's 2 times 51? Yes, 102. Same thing for the other faces. Go ahead and work at your own pace. I'm going to keep my work up so you can check to make sure you got it, but go ahead and finish the rest on your own. All right, go ahead and check your work with mine. So the top and the bottom faces have a combined area of 102, the left and the right a combined area of 36 square inches, and the front and the back a combined area of 204 square inches. So to find the total surface area, my last step is to add them all together. Surface area is 102 plus 36 plus 204. 306, 312, 342. Did I get that? Yes. 342 square inches. Oh, it was centimeters, not inches, square centimeters. All right, pause here to update your work if you need to. Great job, team. Please go ahead and enter your answer for question 3 in the Google form. Again, you can just put the number. If you put the units, if you make an error, the computer will mark it wrong. So just put that number. All right, we're going to move on to question 4. Before we do, I want to give you another strategy for surface area. If thinking about it visually and breaking it apart into top, bottom, left, right, front, back was hard for you, you might really like this second strategy. If you really love equations and algebra, then you might like this strategy better. If you're more of a visual thinker or thinking conceptually, you might like the first one. So you decide, but here's another strategy you can use. This is the formula for surface area of a rectangular prism. It only works to find the surface area of a rectangular prism, okay? And that's all we're doing today. So this is the formula you can use: 2 times length times width plus 2 times length times height plus 2 times width times height, okay? You can use that formula whenever you want to find the surface area of a complete rectangular prism. Just be careful if you're given a word problem that says something like find the surface area of the box, but the box doesn't have a lid, then this formula doesn't work anymore, right? So just be careful, but this is one you'll be able to use for today. All right, I'm gonna let you read, and you can use the formula or you can use the other strategy if you'd like. I'm gonna try the formula for this one. I will put your 1.5-minute timer up. Go ahead and begin. All right, team, let's review. It's okay if you didn't quite get finished. Here's my work. So if you've got really neat organized algebra, this strategy works really well for you if you just need to find the surface area of a rectangular prism. One suggestion I have is to write down what the length, width, and height is. Then you don't need to keep looking back and reading the question and interpreting what your variables mean. So I think this is a great shortcut and a great way to make sure that you've got it. The other thing that I want to remind you of or point out if you haven't noticed already is that each dimension is used twice. So the length and the length, that 4, is used twice, the width and the width is used twice, and the height is used twice. So every dimension is being multiplied by the other one time, right? So length is being multiplied by the width and the height, and the length is not used here. Okay. The reason it's important to know that is just so you can check your work and make sure you didn't make any silly mistake. I got 52 square feet, big star on your paper if you got it, nice work. Of course, you can still use this strategy. You weren't given the shape, but you can visualize it, or just know, even if you don't know top, bottom, left, right, or front, back, you just are gonna use each dimension 2 times to come up with your rectangular faces, okay? We have made it, it's time for the question of the day. Woohoo! Today's question of the day is, what's the formula for surface area of a rectangular prism? I put it here for you. I want you to type it in exactly as you see it here. It's the only way you're going to get it right in when it's graded by the computer. So to make sure that that happens, go ahead and type it exactly as you see here, including that SA, S and A are capital, all the other letters are lowercase. Pause the video here to answer that question of the day. Sweet. You have independent practice to complete today. Your skill builder is area of triangles. So we went over the formula today so that you should ace that. And if you'd like any help or you just want to make sure you're getting an excellent score, go ahead and head to office hours with Ms. Russell today at 3:15. You can make sure your score today is awesome. You can also earn 3 Vista Virtual points. That's it for me. I'll see you guys back here tomorrow.